Hi, today I'm going to talk about rotational symmetry of right prisms. Remember, right prisms have rectangles as lateral faces. Okay. We're going to begin by looking at right prisms that have regular polygons as bases. So we can see our regular pentagon, our regular hexagon, our isosceles triangle, our square. Rotational symmetry in 3 dimensions involves rotating a figure about an axis and having the rotated version coincide or line up with the original figure. The axis of rotation is like a line or a pencil that's inserted through an object at any angle, but we want to find an axis of rotation, an axis that gives us rotational symmetry, called an axis of symmetry. Now, if you think about it, there's always going to be an axis of symmetry that goes through the base shape in the top and the bottom, through the top and the bottom base shape. And we can insert here and get our rotational symmetry. So with that axis of symmetry, how do we determine how many rotational symmetries it will have with the axis that goes through the top and the bottom? Well, that again is determined by the base shape. So if the base here with the regular pentagon has 5 rotational symmetries, the axis that goes through the top and the bottom bases will have 5 rotational symmetries. Or in general, if a base shape has n rotational symmetries, or the base shape has n rotational symmetries, then the right prism with that base will also have n rotational symmetries. But there are other axes of symmetry possible for a right prism. You can also put an axis of symmetry through the lateral faces and edges. So you can think of an axis of symmetry going right through the center of the lateral face here and out the opposite lateral edge, and we can have rotational symmetry that turns it like this. Or if you have an even number of sides on the base, you can see that we can go through the 2 edges, or we can go through the 2 opposite faces and still have that rotational symmetry where we get 2 rotations for each turn. So if you have n sides on your base, you're going to have n possible axes of symmetry, each with 2 rotations. So if we want to look at this as a formula, we can say that we have one axis that goes through the 2 bases, which has n rotations. We have n axes that go through the lateral faces. And each of those have 2 rotations each. And that gives us a total of 2n rotational symmetries that we can have. So together we get a total of 3n rotational symmetries. And we have a total of n plus 1 axes of symmetry. But right prisms that have bases that are not regular polygons can also have rotational symmetry. So let's take a look at the rectangular prism. The rectangular prism has an axis of symmetry that again can go through the two bases, and it has two rotations based on the rectangle. But it can also have two rotational symmetries through the lateral faces on the sides and two rotations through the lateral symmetries on the front and back, giving us a total of 6 rotational symmetries. Right, the cube has special rotational symmetry that is in addition to the normal rules that we're talking about. You should look at the textbook for the cube, but one that you can see here is that you can also go vertex to vertex with the cube and get rotational symmetry this way. So look at that in the textbook. Additionally, we can also talk about the right circular cylinder, which, as you guess, would have infinitely many rotational symmetries. You can have an axis of symmetry that goes top to bottom here with infinitely many rotations based on the circular base. But you can also have infinitely many axes of symmetry that get inserted through the sides, each of which would have the 2 rotations this way.